Hello and welcome to this part of tutorial. In this part we will learn about multiple file compilation and organization of the program. When a program becomes big, you cannot write the entire program in one file. Our programs have been simple and we have written the entire program in one file. However, for big programs, you would like to arrange their functionality in different files. One file may contain several functions and grouped by their functionality. So I have created a simple file here where I call a function mul, which is not in this file. I have two integers. I pass them to this function and it is not in this file. This function is in this file mul.c. Simple function takes two integers and multiplies them and returns them. However, this is not sufficient. We need a prototype, and the prototype is declared in a header int mul int comma int. This header is in the same directory, so we have included header.h. If it would have been in different directory, then we would have to change the path here. Say this is in workspace multifile src. If it would be in src header, then you will have to write header/header.h. Now this is a very simple program, but you get the idea that if I want, I can write more functions here. I can give more prototypes here. Variable declarations can also be given here. Global variables, constants, macros, you can declare in header. Structures particularly. If you want to reuse those in different files, and if you have inline functions, then those should go in this header. Anything which you want to share across various files should go in a header, and the functionality should be split. This is a driver program which will call mul, and mul.c is the functionality. For example, you want to do some computation, square root, you can put in this file. You want to compute power, you can put that in this file, and then you use it. We have already seen how to separate functionality when we were dealing with libraries, and we saw how we create libraries. Now this mul.c can be part of a library. Several files can create a library, and then there can be a driver program consisting of several files which will link to the library, maybe dynamic, maybe static. So we simply build this and we run this. So we get 35. Eclipse does this for you when you add new files and create this. To add a new file, you should know that you can do this by clicking here on the project, right click, and just say new file, add your source file or header file, and it will do. But on command prompt, the way to do it is you go to the directory which contains the files. So how do you compile these files? So one way is to see gcc -o. You give the output file name .exe, and then you supply all the input files, in this case mul.c and multifile.c. So gcc will compile and produce your output.exe. This is one way. However, you may not want this way of compilation, because if you have lots of files, then you would prefer that you do not want to compile all the files all the time, because compilation takes time. It's a very simple program, so it was kind of instant, but compilation of big projects take hours. Some projects may take even a day. So at that moment you would like to simply say, you create the .o file and you create another .o file, and then you link them, output1.exe, and you give mul.o and multifile.o. So you can separately compile them and combine them into one exe, and then you can run output.exe or output1.exe. So that's the trick. And the organization, if you see the organization of programs, then you keep source and header in different directories. So for example, I can create a directory here. I create a directory and then I move header.h to that directory. Then I'll need to do little bit of change in the source code of multifile.c. Okay, I do not have this installed, so I'll go to Eclipse, and that file is gone, and you have got a warning that unresolved inclusion. So you will have to say header/header.h, and then you can repeat your compilation steps either here or if you want, you can repeat the same steps on command prompt. So just to show you, I compile both the files and then I link them together, and I have got output1.exe. That's it for program organization and multi-file compilation. Try to keep source and header in different directories, and that too different functionality should be in different directory. Something which should deal with IO should be in IO directory, something which should deal with, say, math should be in math directory, and so on. This makes it easy to trace the functionality, and you should possibly add the include path to point to your header directories so that there is no problem. And one more thing is that you will not like to corrupt your current directory with these .o files, so you may want to keep these files in a separate directory. As you see, Eclipse usually puts them in debug directory, if you see here. So you see it generates multifile.exe over here. However, it compiles them together, it is not generating separate .os. So similarly, you can create a folder in which you want to keep your .os and then link them together. So this will finish our session on program organization and multi-file compilation. See you in our next session. Thanks. Happy coding.